Arrays are naturally processed with loops. The while loops that we've used so far were a good place to start our study of loops, but there are other kinds of loops that are particularly convenient for arrays. My favorite loop is called a for loop. The for loop displayed will set all 5 elements in the array data to 10. Int square brackets data equals new int of 5. For int index equals 0, index less than data.length, plus index, data of index equals 10. The syntax for a for loop is not as obvious as a while loop. The for loop has 3 areas between parentheses, separated by semicolons. The leftmost area is an initialization. This is done just once at the start of the loop. In the loop you're looking at, int index equals 0 is the initialization. The variable index is declared just for this loop and cannot be used outside of this one loop. The middle area is the test condition. This is the same as the Boolean test condition in a while loop. Just like a while loop, the test occurs before the loop body is done. This means that it's possible to never enter a for loop. This is where for loops get trickier. The rightmost area is done after the loop body is executed, but before the test for the second trip through the loop. I think of this as coming into the loop from the left side the first time and the right side all the other times. You can see the potential for repetition in the flowchart by noticing that the flow of control can circle between the test, the loop body, and the increment. Now that you know 2 different loops, you may wonder how you choose between them. I almost always write for loops. I like them because I don't forget the increment, like I sometimes do when I write while loops. As a general rule, as you become a more experienced programmer, you'll probably write more for loops and fewer while loops. But rest assured that every possible loop can be done either way, although sometimes one loop is prettier than the other. I don't care which one you use most of the time, but you will have to be able to read both of them to understand other people's code. So mix it up a bit when you're practicing programming. Now that we have another loop, let's think about how we can solve an important problem involving loops: sorting data. Sorting data is important because when our data has a better organization, we can be more strategic in our processing. Think about an old-fashioned phone book as an example. If the names weren't put in sorted order, it would be virtually impossible to find anyone's phone number. We've seen that binary search can be much more efficient than linear search because it can take advantage of sorted data. But how does data get sorted exactly? Well, computer scientists spent decades discovering amazing new sorting algorithms. The first one we're going to study is called selection sort. The idea is to select the smallest element and swap it into the first position of the array. You then select the second smallest element and swap it into the second element of the array, and so on. Consider this example. Our array initially contains 4, 7, 1, 3, 5. We'll step through the array one position at a time, finding the smallest number. Initially, 4 is the smallest number at index 0. Since 4 is smaller than 7 at index 1, the index with the smallest number is still 0. 1 is smaller than 4, so now the index of the smallest number is 2. The index of the smallest number remains 2 throughout the rest of the loop because 1 is smaller than 3 and 5. We now swap the data at indices 0 and 2 because we know the value at index 2 is the smallest. Our array now contains 1, 7, 4, 3, 5. If you think about how we would code this idea, you can see that it's the loop below. Int min-index equals 0, for int I equals 1, I less than data.length plus I. If data of min data is less than data of I, min-index equals I. Now we're going to swap data 0 and data min-index. Int temp equals data of 0. Data of 0 is data of min-index. Data of min-index equals temp. That loop is a little tricky. Notice that I initialized the minimum index to be 0 and then started processing when I was 1. There is no reason to start at 0 in this case, since it is the index of the smallest value so far already. This means that our loop doesn't follow the usual pattern of starting at 0 and ending at less than the array length. Now comes the tricky part. We've put the smallest value in the first position. How do we get the rest of the values in the right position? Now we could write another loop after the original loop to get the second value in the proper position. It would look like this. Int min-index equals 1, for int I equals 2, I less than data.length plus plus I. If data of min index is less than data of I, min index equals I. And then we would swap the data again. The problem with this strategy is that the number of loops would depend on the length of the array. Since arrays can be lots of different lengths, we need to be more clever. We need to loop our loops. This is another example of nesting control structures. We've already nested if statements, loops, and methods, so we shouldn't be surprised that loops can nest with themselves. For int start equals 0, start less than data length minus 1, plus plus start, int min index equals start, for int I equals start plus 1, I less than data.length, plus plus I, if data of min index is less than data of I, min index equals I. Now we're going to swap our data. The inner loop is the one we wrote first, but with 0 replaced by the variable start. The outer loop uses the variable start to keep track of how our starting position marches across the array, one position at a time as we swap the smallest values into position. The inner loop will be executed in its entirety for each trip through the outer loop. The pattern of access to the array looks like this. The first iteration accesses all 5 elements of the array. The second iteration doesn't need to access the leftmost element. We know that the leftmost element is the smallest element already, so it can't be the second smallest element. Similarly, we don't need to access the first 2 elements on the third trip through the array. This triangular pattern is typical of computations that use nested loops and is one of the ways to identify when you'll need to use a nested loop in programming. Notice that our last trip through the array accesses 2 elements, not 1. Once we've determined that the next to the last element is the second largest, the last element has to be the largest. You can see this in the algorithm by noticing that the outer loop stops at the array length minus 2, not minus 1 as usual. We'll look at other algorithms for sorting data so you can see other nested loops in action.